Blood-forming organs. The body has a system of cells, the immune system, that has the ability to distinguish self, the organism's own molecules, from non-self foreign substances. The system has the ability to neutralize or inactivate foreign molecules, molecules present in viruses, bacteria, and parasites, and to destroy microorganisms or other cells such as virus-infected cells, cells of transplanted organs, and cancer cells. The cells of the immune system are distributed throughout the body in the blood, lymph, and epithelial and connective tissues, are arranged in small spherical nodules called lymphoid nodules, found in the connective tissues and inside several organs, and are organized and differently sized. Organs called lymphoid organs, the lymph nodes, the spleen, the thymus, and the bone marrow. There are central and peripheral lymphoid organs. Lymphoid tissue may be broadly classified and diffuse lymphoid tissue, dense lymphoid tissue. Diffuse lymphoid tissue consists of diffusely arranged lymphocytes and plasma cells in the mucous or large intestine, trachea, bronchi, and urinary tract. Dense lymphoid tissue consists of an aggregation of lymphocytes arranged in the form of nodules. These nodules are found either in discrete encapsulated organs or in close association to the lining epithelium of the gut. Dense lymphoid organs: thymus, lymph nodes, spleen, and tonsils. Mucosa-associated lymphoid tissue melt. Small numbers of lymphocytes may be present almost anywhere in the body, but significant aggregations are seen in relation to the mucosa of the respiratory, alimentary, and urinary tract. These aggregations are referred to as MELT, mucosa-associated lymphoid tissue in the respiratory system. In the respiratory system, the aggregations are relatively small and are present in the wall of the trachea and large bronchi. The term bronchial associated lymphoid tissue, BELT, is applied to these aggregations. Mucosa-associated lymphoid tissue in the alimentary system, this is also called gut-associated lymphoid tissue, GALT, and include pairs, patches of ileum, adenoids, located in the root of the pharynx, lingual tonsils in posterior 1/3 of tongue, palatine tonsils, and lymphoid nodules in vermiform appendix. The central or primary lymphoid organs generate lymphocytes from immune progenitor cells. The thymus and the bone marrow constitute the primary lymphoid tissue involved in the production and early selection of lymphocytes. The secondary lymphoid organs include the lymph nodes, spleen, the small masses of lymph tissue such as pairs, patches, the appendix, tonsils, and the mucosa-associated lymphoid tissue, MELT, bronchus-associated lymphoid tissue belt. The secondary lymphoid organs serve two basic functions. They are a site of further lymphocyte maturation, and they efficiently trap antigen for exposure to T and B cells. So, red bone marrow. The red bone marrow is found mainly in the flat bones, such as the breastbone, skull ribs, vertebrae, and shoulder blades, and in the cancellous material at the epiphyseal ends of the long bones, such as femur and humerus. Structure of red bone marrow. Red bone marrow is composed of three main components: stroma, hematopoietic cords, sinusoidal capillaries, sinusoids. Stroma consists of three-dimensional meshwork of reticular tissue, which contains reticular cells and reticular fibers, macrophages, adipose cells, cells of endosperm, osteoblasts, osteoclasts, and the thallium cells forming the wall of sinusoids. Hematopoietic component. Hematopoietic cords is formed by the myeloid tissue and contains the myeloid and lymphoid cells at different stages of their development. Note cooperation with stromal elements. Stroma provides the hematopoietic microenvironment that facilitates hematopoiesis by generation of colony-stimulating factors affecting hematopoiesis. Functions of red bone marrow. Production of myeloid and lymphoid blood cells. Proliferation and antigen-independent differentiation of B lymphocyte. Storage in macrophages of iron derived from the breakdown of hemoglobin. Destruction of aged and defective blood cells. Figure 1. The marrow presents numerous adventicular reticular cells, blood vessels, and sinusoids. Note the large megakaryocytes, cells that are the precursor of platelets. Figure 2. This photomicrograph is a high magnification. Two large megakaryocytes are also discernible. Figure 3. This blood smear, a healthy individual, demonstrates the presence of red blood cells, platelets, as well as a neutrophil and the much larger monocyte. Figure 4. Note that the obvious difference between the bone marrow smear and the circulating blood smear is the bone marrow displays many more nucleated leukocytes in various stages of development. Lymphocytes, neutrophils, myelocyte, polychromatophilic erythroblast, orthochromatophilic erythroblast are shown. Thymus. The thymus is an endodermally derived, bilobed, encapsulated lymphoid organ located in mediastinum overlining the great vessels of the heart. The thymus attains its greatest development shortly after birth, but subsequent to puberty. It begins to involute and becomes infiltrated by adipose tissue. However, even in the adult, the thymus retains its ability to form a reduced number of T lymphocytes. The thin connective tissue capsule of the thymus sends septa deep into the organ, incompletely subdividing it into lobules. The thymus possesses no lymphoid nodules. Instead, is divided into an outer darker staining cortex composed of epithelial reticular cells, macrophages, and small T lymphocytes named thymocytes, and an inner lighter staining medulla consisting of large T lymphocytes, epithelial reticular cells, and thymic Hessel corpuscles. Function of the thymus. The thymus is necessary for development of the recirculating pool of small, long-lived, in humans many years, lymphocytes, the T lymphocytes. These cells are mainly responsible for the cell-mediated part of an immune response. Stem cells invade the cortical regions of the thymus, where they divide to form lymphocytes. Only a small fraction, 10 to 30% of the cells generated in the cortex leave the thymus. They migrate via the medulla into the bloodstream to populate the T lymphocyte areas of other lymphoid tissues and organs. Cells which don't express the necessary receptors to recognize antigens presented to them, or which react incurrently towards safe antigen, die and are removed by cortical macrophages. Since the function of the thymus is to produce lymphocytes for the other lymphoid tissues, is a primary lymphoid organ. Blood vessels gain entrance to the medulla by traveling in the connective tissue septa with the exit at the corticomedullary junction, where they provide capillary loops to the cortex. The capillaries that enter the cortex are the continuous type and are surrounded by epithelial reticular cells that isolate them from the cortical lymphocytes, thus establishing a blood-thymus barrier, providing an antigen-free environment for the potentiation of the immunocompetent T lymphocytes. The blood vessels on the medulla are not unusual and present no blood-thymus barrier. The thymus is drained by venules in the medulla, which also receive blood from the cortical capillaries. Epithelial reticular cells form a specialized barrier between the cortex and medulla to prevent medullary material from gaining access to the cortex. Figure 1. This photomicrograph presents a part of one lobe. It's invested by a thin connective tissue capsule that incompletely subdivides the thymus into lobules by connective tissue septa. Each lobule possesses a darker staining peripheral cortex and a lighter staining medulla. The medulla of one lobule, however, is continuous with that of other lobules. The connective tissue capsule and septa convey blood vessels into the medulla of the thymus. Figure 2. Observe the numerous blood vessels in the septa as well as the darker staining cortex and the lighter staining medulla. The characteristic light patches in the cortex correspond to the high density of epithelial reticular cells and macrophages aroused. This is a photomicrograph of the human thymic adult medulla. Note the presence of thymic corpuscle, Hassel's corpuscles, as well as the presence of macrophages and epithelial reticular cells. At this magnification, the two cells are easily distinguishable from each other because the epithelial reticular cells possess lighter staining nucleoli with finer chromatin material than that of the macrophage. Lymph nodes. Lymph nodes are void to kidney-shaped organs through which lymph is filtrated by exposure to large number of the lymphoid cells. They possess a convex surface which received afferent lymph vessels. They also possess a hilum where blood vessels live and enter the afferent lymph vessels, leave and drain lymph from the organ. Lymphocytes enter lymph nodes via the afferent lymph vessels as well as via arterioles that penetrate the lymph node at the hilum, travel to the paracortex within connective tissue trabecula and form high endothelium vessels, post-capillary venules. Each lymph node has a dense, irregular, collagenous connective tissue capsule and septa derived from the capsule, subdividing the cortex into incomplete compartments. Attached to the septa and the internal aspect of the capsule is a network of reticular tissue and associated reticular cells that act as a framework for housing the numerous free and migratory cells, mostly lymphocytes, antigen-presented cells, and macrophages occupying the organ. The cortex of the lymph node houses the capsular and cortical sinuses as well as lymphoid nodules, both primary and secondary, composed mainly of B lymphocytes, antigen-presenting cells, macrophages, and reticular cells. Between the cortex and medulla is the paracortex, populated by T lymphocytes, antigen-presenting cells, and macrophages. The medulla consists of medullary cords and medullary sinusoids. The medullary cords are composed mainly of T cells, B cells, plasma cells that rise in the cortex and paracortex and migrate into the medulla. The medullary sinusoids are continuous with the capsula and cortical sinuses. T cells and B cells enter the sinusoids and leave the lymph node via efferent lymph vessels. Additional cells components of lymph nodes are some granulocytes, aside from functioning in the maintenance and production of immunocompetent cells. Lymph nodes also filter lymph. The filtering procedure is facilitated by elongated processes of reticular cells that span the sinuses of the node and thus disturb and retard lymph flow, providing more time for the resides macrophages to phagocytose, antigen, and other debris. Lymph nodes are kidney-shaped structures possessing a convex and concave surface. They are invested by a connective tissue capsule that sends trabecula into the substance of the node, thereby subdividing into incomplete compartment. The compartmentalization is particularly prominent in the cortex, the peripheral aspect of the lymph node. The lightest staining center region is medulla. The zone between the medulla and cortex is the paracortex. Observe that the cortex displays numerous lymphatic nodules, many with germinal centers. This is the region of B lymphocytes, whereas the paracortex is particularly rich in T lymphocytes. Note that the medulla is composed of sinusoids, trabecula of connective tissue, conducting blood vessels, and medulla cords. The medulla cords are composed of lymphocytes, macrophages, reticular cells, and plasma cells. Lymph enters the lymph node and as it percolates through sinuses and sinusoids, foreign substances and nascent antigenic elements are removed from it by phagocytic activity of macrophages. Afferent lymphatic vessels enter the lymph node at its convex surface. These vessels bear valves that regulate the direction of flow. Lymph enters the subcapsular sinus, which contains numerous macrophages, lymphocyte, and antigen transporting cells. These sinuses are lined by endothelial cells, which also cover the fine collagen fibers. They frequently span the sinus to create turbulence in lymph flow. Lymph from this subcapsular sinus enters the cortical sinus and then moves into the medullary sinuses. It's here that lymphocytes also migrate into the sinusoids, leaving the lymph node via efferent lymph vessels, eventually to enter the general circulation. The cortex of lymph node is composed of numerous lymphatic nodes. One of these is presented in the photomicrograph. Observe that the lymph node is usually surrounded by adipose tissue. The thin connective tissue capsule sends trabecula into the substance of the lymph node. Observe that the lymphatic node possesses a dark staining corona composed mainly of small lymphocytes whose heterochromatic nuclei are responsible for their staining characteristics. The germinal center displays numerous cells with lightly staining nuclei belonging to dendritic reticular cells, plasmablasts, and lymphoblasts. The hilum of the human lymph node displays the collagenous connective tissue capsule from which numerous trabecula enter into the substance of the lymph node. Observe that the region of the hilum is devoid of lymphocytic nodule, but is particularly rich in medulla cords. Note that the basic framework of this medulla cords, as well as the lymph nodes, is composed of thin reticular fibers, aroused, which are connected to the collagen fibers bundle of the trabecula and capsula. The medulla of lymph node is rich in endothelial lining sinusoids, which receive lymph from the cortical sinuses. Surrounding the sinuses are many medulla cords packed with macrophages, small lymphocytes, plasma cells, whose nuclei stain intensely. Both T and B lymphocytes populate the medullary cords since they are in the process of migrating from the paracortex and cortex respectively. Some of these lymphocytes will leave the lymph node using the sinusoids and efferent lymphatic vessels at the hilum. The medulla also displays connective tissue trabecula, connective tissue elements that are conduits for blood vessels which enter and leave the lymph node at the hilum. High magnification of a sinusoid and surrounding medullary cords of a lymph node medulla. Note that the medullary cords are populated by macrophages plus plasma cells and small lymphocytes. The sinusoids are lined by discontinuous endothelium. The lumen contains lymph, small lymphocytes, and macrophages. The vacuolated appearance of these macrophages is indicative of the active phagocytosis of particulate matter. This low magnification photomicrograph of a human lymph node demonstrates that it's surrounded by adipose tissue. The capsule of the lymph node is composed of dense irregular collagenous connective tissue. Note the subcapsulum and the paratrabecular sinuses as well as the lymphoid nodules. Secondary nodules in this instance in the cortex. The paracortex is the T-cell rich area located within the cortex and the medulla. Next picture. This is a high magnification photomicrograph of the cortex of the lymph node in the previous photomicrograph. Note the capsule, the subcapsular sinus, as well as the paratrabecular sinus, the B-cell rich corona and germinal center of the secondary lymphoid nodule as well defined. The paracortex is the T-cell rich area just below the lymphoid nodule. This is a high magnification photomicrograph. Note that the medulla cords are interspersed with medulla sinuses. Spleen. The spleen is the largest lymphoid organ of the body. Its principal functions are to filter blood, phagocytose senescent red blood cells and invading microorganisms, supply immunocompetent T and B lymphocytes, and manufacture antibodies. Unlike lymph nodes, the spleen isn't divided into cortical and medullary regions. No, it's supplied by afferent lymphatic vessels. Blood vessels enter and leave the spleen at its hilum and travel within the parenchyma via trabecula, derived from its connective tissue capsule. The spleen is subdivided into white and red pulps, where the white pulp is composed of lymphoid tissue that is arranged in a specific fashion, either as periarterial lymphatic sheaths, composed of T lymphocytes, or as lymphoid nodules, both primary and secondary, consisting of B lymphocytes. The red pulp consists of pulp cores of Billroth interposed between a spongy network of sinusoids lined by unusual elongated endothelium cells displaying large intercellular spaces supported by three discontinuous hoop-like basement membrane. Reticular cells and reticular fibers associated with these sinusoids extend into the pulp cores to contribute to the cell population that consists of macrophages, plasma cells, and extravasated blood cells. A region of smaller sinusoids forms the interface between the white and red pulp, and its interface is known as a marginal zone. Capillaries arising from the central arteries deliver their blood to sinusoids of the marginal zone, which is rich in arterial vessels and avidly phagocytic macrophages. Antigen-presented cells of the marginal zone monitor this blood for the presence of antigens and foreign substances. Understanding splenic organization depends on appreciating the vascular supply of the spleen. The splenic artery entering at the hilum is distributed to the interior of the organ via trabecula as trabecular arteries. On leaving a trabecula, the vessel enters the parenchyma to be surrounded by the periarterial lymphatic sheath and occasional lymphoid nodules and termed the central artery. Central arteries enter the red pulp by losing their periarterial lymphatic sheath and subdivide into numerous small straight vessels known as penicilla arteries. Penicilla arteries possesses three regions: pulp arteries, sheath arterioles, the terminal arterial capillaries, where these terminal arterial capillaries drain directly into the sinusoids. Closed circulation, or terminate as open-ended vessels in the pulp cords. Open circulation hasn't been determined conclusively. However, in humans, the open circulation is believed to predominate. It's during this passage of red blood cells from the splenic cord into the sinusoids that damaged and aging red blood cells are eliminated. Sinusoids are drained by pulp veins, which lead in trabecular veins and eventually join the splenic vein. In this scheme, you can see the splenic circulation, schematic representation. You can see open and closed circulation. The spleen, the largest lymphoid organ, possesses a thick collagen connective tissue capsule. Since it lies within the abdominal cavity, is surrounded by simple squamous epithelium. Connective tissue septa derived from the capsule penetrate the substance of the spleen, covering blood vessels into the interior of the organ. Histologically, the spleen is composed of white pulp and red pulp. White pulp is arranged as a cylindrical, multi-layered sheath of lymphocyte surrounding a blood vessel known as central artery. The red pulp consists of sinusoids meandering through the cellular tissue known as pulp cords. The white pulp of the spleen is found in two different arrangements. The one represented in this photomicrograph is known as periarterial lymphatic sheath, composed mostly of T lymphocytes. The zone of lymphocytes and the junction of the periarterial lymphatic sheath and red pulp is known as marginal zone. Lying within the periarterial lymphatic sheaths of the spleen, a second arrangement of white pulp may be noted, namely lymphatic nodules bearing a germinal center. Lymphatic nodules frequently occur at branching of the central artery. Nodules are populated mostly by B lymphocytes, which account for the dark staining of the corona. The germinal center is the site of active oxygenic challenge. The marginal zone, also present around lymphatic nodules, is the region where lymphocytes leave the small capillaries and first enter the connective tissue spaces of the spleen. It's from here the T lymphocytes migrate to the periarterial lymphatic sheaths, whereas B lymphocytes seek out lymphatic nodules. Both the marginal zone and the white pulp are populated with numerous microphagous and antigen-presenting cells, in addition to lymphocytes. The red pulp of the spleen presented in this photomicrograph is composed of splenic sinusoids and pulp cords. The splenic sinusoids are lined by a discontinuous type of epithelium, surrounded by an unusual arrangement of basement membrane that encircles the sinusoids in the discontinuous fashion. Sinusoids contain numerous blood cells. Nuclei of the sinusoids lining cells bulge into the lumen. The region between sinusoids are occupied by pulp cords, rich in macrophagous reticular cells, plasma cells. The vascular supply of the red pulp is derived from penicillar arteries, which give rise to arterioles, whose endothelial cells and smooth muscle cells are evident in the center of this field. The connective tissue framework of the spleen is demonstrated by the use of silver stain with precipitate-surrounded reticular fibers. The capsule of the spleen is pierced by blood vessels that enter the substance of the organ via trabecula. The white pulp and red pulp are clearly evident. In fact, the lymphatic nodule presents a well-defined determined center as well as a corona. The central artery is also evident in this preparation. Reticular fibers which form an extensive network throughout the substances of the spleen are attached to the capsule and to the trabeculum. This low magnification photomicrograph of the human spleen displays its dense irregular collagenous connective tissue capsule covering by a simple squamous epithelium. Septa rising from the capsule convey blood vessels, arterial vessels into the venous vessels out the spleen. Instead of the cortex and medulla, the spleen is subdivided into white pulp composed mostly of lymphocyte and red pulp composed mostly of venous sinusoids. The boundary between the red and white pulp is known as marginal zone. The white pulp is organized into lymphoid nodules, mostly B cells, and periarterial lymphatic sheath, composed mostly of T cells. The center of the pulp is occupied by central arterioles. This photograph is a high magnification of a lymphoid nodule similar to the lymphoid nodules of the previous figure. Note that the corona of the lymphoid nodules is surrounded by the periarterial lymphatic sheath, which in turn is surrounded by a marginal zone. The red pulp and the piece of the septum are also identified. Thank you.